Okay, so today we're talking and we're taking notes on determining if a domain and range is reasonable. So we're checking it for it to be reasonable or reasonableness. So what reasonableness is referring to is the set of input and output values make sense within the context or specific real world problem. Okay, we apply logical constraints to the function. So reminders with discrete. These are countable and they're written using the brackets. Continuous, these are measurable and they're written with the inequalities. So less than and equal to, less than. Okay. And then our steps for this, we determine if the function is discrete or continuous. And then we write the domain and range and make a table. It might be best to make a table or write the equation. And we want to identify these minimum and maximum values. These are the things that are going to determine if something is reasonable, okay? As a reminder, remember domain, these are your x values, and range, these are your y values. So, graduation tickets cost $15 per person. Each student can buy a maximum of 3 tickets, okay? So, the first question is this discrete or is this continuous? So, each student can buy a maximum of 3 tickets. So, can you have half a ticket? No. That immediately tells me that this is discrete. Okay? I'm going to make a table, especially when it's discrete. It's best if I make a table. So, let's talk about this. A student can buy tickets that cost $15 per person, and each student can buy a maximum of 3. So, they can buy 3 tickets. That's my maximum. They could also buy 2 tickets. They could also buy 1 ticket. They could also buy no tickets at all. Okay. So if they bought no tickets, that means they spent $0. If they bought 1 ticket, they spent $15 because each ticket costs $15. If they bought 2 tickets, that would be $30 because 15 plus 15. And if they bought 3 tickets, that would be $45 because 15 plus 15 plus another 15. So my domain is right here, my x values. And so because this is discrete, I write it in brackets. And I'm going to write it least to greatest. 0, 1, 2, 3. My range values, these are my y values. And again, I'm going to write it least to greatest. 0, 15, 30, 45. Number 2, Sam is planning to buy at least 1 pound of chicken, but no more than 4 pounds. The store sells chicken at $2 a pound. The total cost of the chicken is a function of the total number of pounds purchased, which makes sense because if you're buying food like this, if you bought 1 pound, it should cost less than if you buy 4 pounds because it's based on the amount that you buy. So now the question becomes, is this discrete or is this continuous? Are you counting here? Is it strictly 1 pound or is this measurable? So this is measurable because you could have 1 pound or 1.5 pounds or 2.5 pounds. So because of this, because it's measurable, okay, this will be continuous. So if I made a table, okay, number of pounds, right, and then cost, number of pounds right here, this is going to be my x value because that's going to be my independent value. My cost depends on it, so that's going to be my y value. So the lowest amount that he wants to buy is 1 pound. He wants to buy at least 1 pound, but no more than 4 pounds. So he's going to buy somewhere within this space. Well, for 1 pound, it's $2 because it's $2 per pound. And if I buy 4 pounds, that would be 4 times 2, which is $8. So my domain is going to go from 1 less than x less than 4. It's going to stretch here. Now, here's my next question. If I bought at least 1 pound, does that mean I would include a pound? At least? Yeah. That means I would include that pound, but no more than 4 pounds. So could they buy 4 pounds? Yeah, because that's not more than 4 pounds. So these are both less than or equal to. Because they are less than or equal to, that actually makes my range easier to understand, because now my range is also going to match that. And for 1 pound, it only costs $2. And for 4 pounds, it costs $8. So my range is 2 less than equal to y less than equal to 8. I can't spend more than $8 because they're not getting more than 4 pounds. I can't spend less than $2 because he's at least getting 1 pound. Question number 3. A company is collecting donations for charity. The total amount collected, y, is a function of the number of days spent collecting, x. Okay, so this one's kind of odd. Let's talk about this one. It says a company is collecting donations for a charity. The total amount collected, y, is a function of the number of days spent collecting. Well, if number of days is kind of deceiving, because number of days makes it sound like it's discrete, but could we measure the amount of days? Is that measurable? Yeah, we could have 2.5 days, 3.5 days, 4.25 days, something like that. We could break the days down to hours, to minutes, to seconds. It wouldn't have to distinctly be counting. So this would actually be continuous. Now, here's the other issue with this. The other issue is it doesn't say how long this happens for. All we know is that they do this. So the number of days, this is going to be days, and this is going to be money. So what's the least amount of days? Well, I guess the least amount of days would be 0, right? And if they collected for 0 days, they collected 0 money, right? But beyond this, we don't know where this stops because they don't put an endpoint on this. So my domain would be all the x values that are greater than or equal to 0, because they could spend as many days as they would want based on this. They didn't say when it had to stop. And because of that, my range would also be less than or equal to, or greater than or equal to 0, because they could collect so much money during that time. I don't know how the two things are related mathematically. I just know that the number of days spent collecting is going to impact the function of y, which is the amount of money they collected. Number 8, this is a pretty common one. It says a presenter, has 180 cookies to give away after each of his 6 presentations he is made. He plans to give away 30 cookies after each presentation. The number of cookies left, y, depends on the number of presentations made. So now let's ask this. He plans to give away 30 cookies after each presentation, and the number of cookies, y, left depends on the number of presentations. Okay, so there's number of again. That's a huge indicator that it's going to be discrete. So let's go back up here. Are the number of presentations and the number of cookies countable? Yes. Would we ever do like half a presentation, or would we ever give away half a cookie? That doesn't make any sense. So here, my function is going to be discrete. Now let's work out this table. So we have this presenter, and he's going to present 6 times. So 0, 1, 2, 3, 4, 5, and 6. Okay? And while they're presenting each time, he's going to give away cookies. He starts with 130 cookies, or 180 cookies, excuse me. And after each presentation, he gives away 30. So I'm going to be taking away 30 every single time. So 180 minus 30, that's 150. 150 minus 30, that's 120. 120 minus 30, that's 90. 90 minus 30, that's 60. 60 minus 30, that's 30. 30 minus 30, that's 0. So my domain is 0, 1, 2, 3, 4, 5, and 6, because that's the number of presentations he has. My range goes up. Oops, that's supposed to be brackets. 0, 30, 60, 90, 120, 150, and 180. So that's how we write the domain and range for and reasonable domain and range with real world examples. The first thing we identify is it continuous or is it discrete? Then if you notice, every single time I built a table to try and identify how much my domain is and how much my range is. And we break down the problem. Don't be afraid to underline things, cross things out, work through these problems. If you notice, I'm using a bunch of different colors. That helps me out, but do whatever helps you out to solve these problems. Okay?